Okay, sorry about that. I had 8 Chrome windows open where I could hear myself talking, so that was a little bit disorienting. Ooh. Okay, so welcome to the Sometimes Sunday Math Show. This is in case you are curious about math and want to learn math with me. Who am I? I'm John Maida, and I sometimes understand math. And let's see how I can do here. All right. Okay, so first of all, let's check this out here. A little dangerous. Okay, looks good. What's the field? A little higher. Okay. Field is good. All right. Let's see here. Oh, good, good. Okay. Let me adjust. Let's see here. Could be dangerous. I don't want to like surprise your head here. Let's see, range is here to here. Okay. All right. So first of all, we're gonna do 3 things today. We're gonna talk about Pythagoras. He's a pretty amazing person. We're also going to dig into trigonometry, which isn't everyone's favorite, but it's my favorite because it lets you draw things, because drawing things is a lot of fun. Okay, so let's see here. Good. All right. Okay. Yeah, sometimes Sunday is sort of very random at times. If you were here last Sunday, you saw me go over how you count in bits, 8 bits. We used coins, we marked them with sides on them, and we're able to figure out how we count to 256 with bits. Hope that was useful to you. Useful to me. All right, I need tape. 1 second. Okay, why is math good? Whoa, don't break anything. Why is math good? Math's good because it's kind of mysterious. You can do things like this. Let me give you an example. This is, oh my gosh, my hands are upside down. Whoops. Okay, clearly I'll have to, oh my goodness, how do I do that? I'll get on that side. Okay, 1 second. Let me reverse the direction. 1 second, this is live, therefore, and I'm the AV person, so pardon me. Okay, let's see here. Take this, rotate it. There we go. Much better. Okay, magic. All right, rotated. Oh, my hands, right direction. I love that. Okay, so, a second here. This camera, rotate it here, easier to sit. Okay, good. All right, good. Whew. Sometimes Sunday is a stressful thing, but I like live because I don't have to prepare anything, and if you have time to watch, you can always 2x me. It's okay. It's it's a free world. So this is a half piece of paper. Do you see it? And I have why do I love math? I love shapes. I love shapes and how things turn out. So let's sort of let me tape this loop together. So this is one of my favorite things. It's like cooking things. This is the Mobius strip or Mebius strip. Depends upon what language you speak to say that correctly. But this is a regular ring. Do you see how I taped it together? Not very exciting. But this ring, watch this. I'm about to close it, and whoa, wait for it. Put a little twist in there. Put a little twist. You see my twist? And with that one twist, magic happened. And let me show where the magic happened. So, the magic is if I just do this, scissors, these are very sharp, be careful. I should look here while I'm doing it so I don't cut myself. So very sharp. If I cut all the way through the middle of this loop, what do you expect is going to happen? What do you expect? I'm gonna cut that loop, and there you go. What happened? I got like 2 loops. Right? Okay. Let's take the Möbius strip. All right, watch this. It's very exciting. I'm gonna take this loop, and I'm going to chop it, and there we go. Whoa, what's the deal? Okay, I'm gonna cut it. Cut it all the way through. So it should be 2 loops, but it's not. It's like, it's one gigantic loop. It's like an Hermes band, like on an Apple Watch, the fancy Apple Watch band. It's like, whoa, Hermes. Right? Strange, huh? Well, that's why math is cool. Math's like weird. And when you think about those who are good at math and those who aren't good at math, I kind of think it's like how you're taught it, or like maybe you were better at something else. Maybe you were really good at social sciences, or maybe you were good at PE, right? So I think math is something that people who aren't good at the other things end up doing, maybe, or something. But anyways, I was good at math, but didn't really understand it. Good at like rote things, calculations and stuff like that, boring stuff. But so anyways, do you feel that? Maybe a strip? Pretty good. Try it yourself. It's like magic. Okay, and be careful about your scissors and stuff, because they're very sharp nowadays. Okay, so again, we're doing math, M-A-T-H. All right, make America think harder. Okay, so this is episode 3. Episode 1 and 2 began looking at 8th grade math. I'm going to stay in 8th grade math all the way through episode 4, because there's more 8th grade to do. Going to do statistics next. Sometimes Sunday means sometimes I do it on Sundays. Sometimes I might not. It's a hobby. But when you think about it, I was looking at grade 8 and how we learn math. And the number system, touched upon that. Oh, let's focus. Number system, we did some equations, we did some functions, and we're now going to do some geometry, and then if we make it to episode 4, we'll do some stats probability. Okay? Sound good? Okay, I can't see you, but I'll guess you're nodding. Okay, let's put this away. These are very useful, by the way, these dots, useful for like, voting and stuff like that, but now everything is remote, so we use Miro or any kind of whiteboarding system. Okay, what do I want to do? Pythagoras, yes, Pythagoras, what a cool person. Like, Pythagoras, did you know Pythagoras was one of the first known vegans? Because Pythagoras figured out that some of the Egyptians were like living much more healthily, and he didn't eat meat, so he's the first vegan. I am not a vegan, but if you're someone who's a vegan, that's even more reason to love Pythagoras, Mr. Pete. Okay, so let's do something that I've always wanted to do, which I didn't know why. Okay, a sip of tea, 1 second. Always take a break, because this is like not meant to be stressful. Okay. So, Pythagoras' theorem, I'm sure you've heard of it. It's like a thing. It's like a squared plus b squared equals c squared. You use it a lot. It's pretty powerful. Now, why does it matter on the computer? Well, it matters because whenever you have like a mouse, you have a mouse, you click, and you like move the cursor around the screen. You want to know like the distance between 2 points on the screen. You're using Pythagoras' theorem, right? Well, maybe you knew that, but I didn't think about it quite deeply until recently. I was like, oh my gosh, Pythagoras is everywhere. Let's show you how and why. So this a squared plus b squared mess, what is it? Well, it turns out that Pythagoras figured out, I'm using my scissors again. Okay, it works. All right, so like Pythagoras figured out this weird relationship, and I'm going to interpret it more as an area relationship. Area, perimeter is the kind of the distance around something, and area is the amount of squares that fit inside it, right? So Pythagoras, I don't know what he was doing. Maybe he was like really into squares, or I don't know. Like what did he do when he was young? I'm not sure, but he definitely ate the right things. So maybe this vegan thing is really good. So I'm gonna cut a square that is, by the way, I have people walking over my head. If you live in an apartment, this is very normal to you, but this is sort of very, very noisy in my house today. So that's what's happening up above me. Okay, and so that's a 4, right? That's a 4. Sort of focus, make sure we're focused. That's a 5, and let's make a 3. I'm gonna make a 3 by 3. And you can do this in your own home. I just made this like 20 minutes before I hit the kind of like play button, but this is a 3 by 3 square. Okay, so I hope this works, because like I just thought of this. I'm not sure if it's gonna work. It better work. Math, come on, work for me. I've got like a 3, 4, 5. You feeling it? Okay, let's sort of like zoom back. Whether my camera is running on battery, so this may come on. So anyways, we like to you know, play chicken a little bit with the live video whenever we can. So that's a 3, 3 by 3, 4 by 4, 5 by 5. So the neat thing about a 3, 4, 5 triangle is that, let's see if it happens. Oh my gosh, look at that. Isn't that incredible? That's the famous 3, 4, 5 triangle. And it says that let's call this a squared, and let's call this b squared, right? A squared, b squared equals c squared. What does that mean? I think it means that if this is like, let's call this b. Let me just sort of use a pen so you can see it, not to match what I'm saying. Let's call this the b. Let's call this a, yeah? And let's call this c, all right? So a squared is the area of the square. B squared is the area of the square. C squared is the area of the square. Wait for it. Does that mean that a squared plus b squared equals c squared means the total area of these two equals that? I don't know. Let's find out. I'm a little bit afraid to do this because okay, here we go. Here we go, everyone. Ready? Oh my gosh, I'm gonna put a little b in there. Whew, is this gonna work? I don't know. You know, it's a little bit dicey here. I've never done this before. It just occurred to me before I was to begin this math show, this might be true. Oh, look at that. Isn't that neat? Look at that. So wait a second. Wait, is that real? So a squared and b squared equals c squared. Pythagoras, what were you doing when you figured this out? And so Pythagoras figured out, just from that little bit of magic, that if you have this relationship with a right angle, he did more stuff than this, mind you. He didn't have like scissors and paper, I'm sure, maybe sheepskin or whatever. But like, right? Isn't that kind of magical? Okay, that's like enough to like take a break on. But before the power in my camera runs out, let's talk about how this lets you calculate the distance between 2 points, which is what we do on the computer all the time. If you're ever doing like math on the computer, again, let's thank Mr. Pythagoras. Mr. P, you rock. If we have, I drew these pictures of things. One second. Oh, no, so let's use this. Okay. So when you think about the distance between 2 points, this point and this point, that distance on a Cartesian coordinate system. Isn't that a cool word, Cartesian? It's like that artesian brewery thing. What is that? Rainier beer? I grew up in Seattle. So anyways, if we have these 2 points, how do you figure out how far they are from each other? Well, you have a right triangle. So you take the distance between this point and this point, and this point and this point. You square them and get to take the square root. So this is like often called x0, x1, y0, y1. This distance here is y1 minus y0. This distance here is x1 minus x0. And then the square of this is equal to the square of this distance. So all you need to do is take the square root of this plus this, and you get this magical number. And that distance calculation happens. Like everything we do on the computer requires distance calculation. So Pythagoras, one more time, Mr. P. Pythagoras, where are you? Wow, you like enabled us to do computer graphics. Thank you, Pythagoras. Okay, so we covered Möbius strip, we cut one, we did Pythagoras theorem, and actually covered distance. Let's talk about sine cosine, shall we? Because that's something kind of fun, isn't it? Sine cosine. No, yes, sine cosine. Let's do that. Okay, so sine cosine. You know sine and cosine? Actually, I have a book. I forgot the book. I have this book I got on an eBay auction. It's the WPA. You know, during the Depression, the U.S. government funded different projects, and there was a project that was funded. Whoa, excuse me. I'm sitting on like a ledge here. There was a project funded to calculate all the different trigonometric values by hand. So there's this gigantic book I have. There's like 4 of them. It's called the tables of like trigonometric and logarithmic functions, all by hand, out to I think 4 decimal places. But anyways, it's in the history of computers was that humans did all the calculations. They were called computers at the time. This is in How to Speak Machine, so if you heard this already, I'm sorry for boring you, but I find it fascinating to remember this, that humans were the first computers. Okay, so sine, cosine. You have like a scientific calculator. It's not on the basic calculator. You punch in a number, you get the sine of it. Sorry, there's like lots of pet action above me. Sine, cosine. So sine and cosine are really cool because they are expressions of a triangle relationship. So let's talk about that. So sine, cosine. So first of all, let's imagine that, let's see, I drew this to make it easy to understand. One second. Sometimes Sunday is really sometimes Sunday. It's meant to be. Yeah, okay, good. All right, so let's go off-road. So when we think about sine and cosine, let's draw this rectangle over here. And this is theta, and this is opposite, adjacent, and hypotenuse. You may remember the SOHCAHTOA phrase. Sound familiar? SOHCAHTOA, kind of like rolls off the tongue. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I don't know how you remembered it. There's different ways to remember this. But SOHCAHTOA is useful because you don't have to remember it like the other way. This is how I remembered it. So the sine of theta, in this case, ooh, you can't see it. Sine of theta, you take the opposite over hypotenuse. So this number divided by that number. You take, for cosine, you take this number A, you put it over H. And then you can like measure it. You can like, calculate with your ruler and like, figure this out. And it's kind of cumbersome. So human computers have already like computed this already for us. They've already gone ahead and like calculated these numbers for us. They're in tables. And inside the calculator, they're like instantly accessed. Remember floating point numbers versus integer numbers using floating point numbers. But the thing to remember is that the way sine, cosine, tangent work is they're really confusing until you realize that if you apply it to a circle with radius 1, then everything becomes awesome. Everything becomes awesome. Okay, I wish someone told me this when I was younger, then I wouldn't have had to be so confused. Maybe you knew this. You went to a better whatever. You had better teaching. Maybe I had great teachers, mind you, but maybe I was not thinking so much as a child. So let's assume that this distance here. Let me draw this line here. This is a circle, radius 1. So this is always going to be 1. Now, that's kind of hard to sort of feel, right? Well, let's say like here, that's 1. And this is like 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, that's a 9, 10, 5 plus, wait. Oh, wait, wrong sheet. Everyone pause for a second. Okay, there we go. New program in the matrix. Phew. Right over there. Move this over here. Don't drop it. Perfect. Okay. So this is 10 squares. Can you see? Let me let you zoom in a little bit. All right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So any line is going to be 1 long. Let's assume we're like zoomed up, and let's say this is equal to 1 centimeter. And each of these little tiny things is 1 millimeter. So when you have, if this is 1, this hypotenuse is 1, and you want to understand like what the sine is, ta-da, this distance on the y-axis. Isn't that amazing? So I want to cry when you hear that. and the cosine is this distance here, x. That's the cosine. So like think about what's a common thing we might remember from trig? It's like a sine of 45 degrees, right? So if this line is 45 degrees and I'm measuring this, this is going to be, what is it, sine 45? Whatever. You look it up, everyone, wait a second. Here we go. 1 second here. Let's do this correctly. In the 2020, Google can do everything. So let me see here. So you can like type into your calculator sine 45. Yeah. That's in radians. I want sine 45 degrees. Come on, I want to speak like my language. Okay. 0.7017. So it's I thought it was 0.7 by drawing. Oh, it is right. Okay, there we go. So it's 7 of these, roughly 7 of these units. So there we go. And also it's 7 of these too. We can do the same thing. Let's get risky here, folks. Let's do sine of 60. A much more okay. There we go. Sine 60 degrees. Sine of 60, so it's a bigger angle, right? Like that. Let's say that's roughly 60. It's going to be 0.86. And what is the cosine of 60 degrees? Oh, it's 0.5. Kind of right, huh? 0.5, halfway. So it's a way to relate to this hypotenuse moving around the circle, and a way to quickly figure out what is the x and y using and underlying it is Pythagoras Theorem, like working away. You know, that distance and that line, you see that, right angle? And why is this useful? Well, first of all, distance, super useful in any kind of computer graphic calculation. You know, touch, you know, distance, dragging lines, etc. But sine, cosine, so critical to drawing circles. Well, why? Well, do you see here that this is a circle? And the best way to do this, I'm sorry, I wasn't able to make a fancy computer graphic of this, but if you take this, okay, let's take this, everyone look at me. Let's go to the camera now. If I took this and I looked at this from the side and I plotted out all the different values, like, or as I'm headed around the circle, just from this view here, what would happen is you would see something like this, like that. Does that look familiar? This kind of thing? You would see this pattern, which we know is sinusoidal. If you just looked at it from this direction, you would just, as you're tracing around the circle in even steps, you would get this sinusoidal wave. And I can't tell you like how useful this sine cosine thing is, because it's beautiful because it's tied to this circle, right? Like this circle is the basis of that calculation, and the sinusoidal is tracking this circle's beautiful geometry. And so when we're accessing sine cosine, we're accessing the mysterious space of a circle and the xy coordinate system, and then we throw in time to get a sinusoidal. And with that, you can make circles, you can make things, you can make pendulums swing, you can make so many things. There's also something called Perlin noise. Look it up. Perlin noise can drive things like furry things, fuzzy things, synthetic. Many of these landscapes you see in computer graphics all deal with sinusoidals. Last bit of exciting things about sinusoidals is a lot of the modeling of even this video image that's getting to you. It's part of it is probably breaking it down into sinusoidals as well. So it's using something called a Fourier transform. Maybe heard of Fourier transform. It sounds like furry transform. But it's like it all came from over here, the circle. And the bones of understanding this hypotenuse relationship all began from Mr. P. And I don't know. I'm kind of psyched. I'm kind of psyched that we did this together, even though I wish I was slightly more organized. But that's the thing about Sometimes Sunday Math Show. Let's go over here to finish. Okay, we're back. Well, thanks for listening in to Sometimes Sunday Math Show. It is always sometimes. And I have an elaborate setup here. As you can tell, I don't know where to look anymore. But I'm figuring out how to do this YouTube thing. And thanks for being curious along with me. And let's see where this goes. So episode 4, we'll talk about statistics. All right, thanks for tuning in.